In our society, we often experience a tension between the privacy of our data and the utility of its use. For example, assume that you want to rent a house and the landlord asks you to prove that your monthly income exceeds the rental fee. Now, you will not like to reveal exactly how much you earn because, for example, this may induce the landlord to increase the price in the future. So, how can you then make this proof and without revealing too much information? So, zero-knowledge proofs are a magical cryptographic tool that allows to prove that a statement about private data without revealing more information than the fact that the statement is true.
So let's see a physical example of how we could do that. So how can we convince the landlord that we can afford the rent? So suppose that the rent costs 4 coins and we earn 10 coins. And we insert those 10 coins inside this opaque coin dispenser. So from the shape of the dispenser, at least you can see that I have 3 coins. So how can I prove to the landlord that I at least have 1 more? So it's very simple. I simply get this one out, and now you can see that I have 1, 2, 3, and 4. So the landlord knows that I can afford the apartment, but he has no clue about our spare manual. So this can look quite simple in this toy example, but what happens when in a digital transaction you have to convince someone else on the other side of the world? So this is where cool mathematical techniques come into play and make it possible.
Unfortunately, we've been having these cool mathematical techniques for a while, for at least 30 years or so. But it's now that some emerging technologies like blockchains or cryptocurrencies are coming out that are pressing us to make all these systems practical. Now recently at IMDEA, what we did was tackling 2 of the main challenges in this space. The 2 main challenges here are, one, that these things, the digital analogies of the physical world, opaque coin dispensers, these things are very complex. And the other is that they're slow. So in order to tackle these problems, we developed a framework called LegoSNARK. Basically, we design techniques that allow to construct these systems not in a monolithic way, but more modular. So think of not a whole piece of clay, but made of different construction blocks or so. And that's why we call it Lego. And the interesting thing is that this approach also gives you more efficient zero-knowledge proofs in general.